So this is a review of how to complete the square, but this is really intended for calc students. And honestly, this review is intended for when you need to complete the square within an integral. So this is like a specific trick, very often in like a Calc 2 class. So I'm just going to jump right into it. So what we're going to do is we're going to complete the square on a handful of different polynomials just so you can kind of practice the skill without an integral. And I have other videos where I talk about completing the square within an integral so you can see it all put together. But let's just focus on this skill for now. So completing the square is like, so when you're completing the square, you're really talking about the squared term and then the regular x term. This is what you complete the square on. And so in this particular problem, I just have it focused on the thing that we need. And with completing the square, you're always looking for whatever is attached to the x term. This is your b. Once you identify your b, the rest of this is just an automatic process. You identify your b, and if it's positive, you make it positive. If it's negative, you make it negative. So in this case, it's going to be -4. Then you take half of that, and then you square that result. So this is what completing the square is. You identify your b, take half, and then square it. And I strongly recommend you write out, boom, 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 these 3 steps. Don't do it in your head. Just write it out. And after you get to this half b squared, so maybe I'll just mark this in blue so that we can kind of keep track of this. So this number, we're going to add and subtract into our polynomial. So specifically, I'm going to have x squared minus 4x, and then I'm going to both add and subtract this number here. The reason why is because if I add and subtract it, this is effectively adding 0, and it won't change the value of the polynomial. And then what this allows me to do, so usually the point with completing the square is that we want to be able to write kind of this set of terms here, so the thing that you added in, we want to be able to factor this as a perfect square trinomial. So specifically, just to take this one more step further, so the way that this factors is it's always going to factor as x, and then whatever this is here, this half b, that's always the other part of your perfect square trinomial. So it's x minus 2 squared. So I have factored just this part here, and then I've got the -4. And so this now is everything kind of completed the square. We're kind of done with the whole thing. So that's the process, okay? All right. So let's do it again. And so let's do it with, now I've got an extra number here. So we're just going to ignore this. When you are completing the square, you are only ever focused on the x terms. And so I go through the same round. My b is 6. My half b is 3. And my half b squared is 9. Okay, so this is actually going to be a little bit interesting, and we'll think about this a little bit more at the end. Okay, so what I'm going to do then is this 9 here is going to get added and subtracted into my problem. So I have x squared plus 6x and then plus 9. I have this other 9 here, and then I'm going to subtract it out. Okay, so let's think about what is happening here. So to factor this, this becomes x plus 3 squared. So remember, when I am factoring this here, it is always just whatever my 1/2 b is. And now when I complete this operation out here, 9 minus 9, this is just this plus 0. Okay, so does this result make sense? So yes, it does, because if you look at this original problem, I could have just factored this as is. Like this already was a perfect square trinomial, I guess is what I'm trying to say. So we just completed the square on something where we didn't really need to, and it still worked out to be a perfect square trinomial, so we can like very much believe the process of completing the square is what I'm trying to say. Okay, so let's add just a little bit more complexity into this now. So one of the keys with completing the square is that your x squared term needs to have a coefficient, so maybe I'll just write needs coefficient of 1. And so this is what can make things a little bit tricky now. And so this is one of the things that you have to watch out for. So you can't, this is an expression. We can't just go dividing out the 5. right? It's not an equality, so I can't just go changing it. So instead what I have to do is I'm going to factor out the 5, and I can factor that out of all the terms here. And now I can work on completing the square. Now, there's kind of two thoughts, I guess, on how you can factor out the 5. I feel like what happens is most of us want to factor out like this, and this is okay. But I actually think that the better way to do this would be to just factor the 5 out of these two terms here and leave this thing at the end alone. But you know what? I'm actually going to do this both ways, and you can decide what makes more sense to you. So, but I want to do it both ways just so that you can kind of get what I'm talking about here. So let's start with kind of this natural way of, like, I think a lot of people just factor out the 5. Okay, so I factor the 5 out. Remember, I am completing the square here. So what I want you to do is, just to make sure that you're getting this, complete the square on these terms here, and your adding and subtracting will now happen within the realm of this set of parentheses. So go ahead and set up the whole thing and hit play when you've kind of gotten to that point, just to check in on how you're understanding this. Okay, so my b is -4, my half b is -2, my half b squared is 4. So this 4 is going to be added and subtracted within this set of parentheses. So this is x squared minus 4x, and then I'm going to have plus 4 and minus 4, and then I've still got that minus 2. Okay, so the thing that I add on, this is where I want to write my perfect square trinomial. So now I'm just going to make a bigger set of parentheses. So this is going to be x minus 2 squared. So that's from here to here. And then I just need to finish this operation here. Okay, so this becomes minus 6. Okay, so now technically this is completing the square, but where this can get funky if you are working in an integration problem is that you might not want to have this whole thing kind of set up like this. It kind of depends on how you're looking at the problem. So what I'm trying to say here is, you might want to distribute this 5. You might want to distribute it back out. It might be helpful for you. And if you did that, this would become 5 times x minus 2 squared minus 30. Okay, so this is one way to look at this problem. And now I just want to slightly change the lens, just so that you have different ways of looking at this. And you should really, stick with the one that makes more sense to you, but sometimes it's nice to have flexibility with these things. So let me make a clean slate here. So another way that you could think about this is you can factor out, oops, wrong color. Let's factor out just the 5 on the part that you're completing the square on. So I only factored the 5 out of the x's. And so then I can go, about my business of, completing the square. So I go through all my happy little steps here. And so now I'm going to have this 5 times x squared minus 4x, and then my plus 4. Now, here's where this can get a little funky. You're trying to keep everything in balance. So I've added a 4 here. So it makes sense that I need to also subtract that off to not impact the balance. So an alternative way that you can think about this is, I have set this up now as my perfect square trinomial, and I need to back out this 4, but look at how the mechanics of this works. This 4 is ultimately being bounced off of this 5. So when I back out this number that I added in, I also need to, need to reverse the operation that's happening as it's getting multiplied by this thing here. And so what that means then is that I need to subtract off 5 times 4. Okay, so this is the other way that you can kind of think about this process. And I think it's good to know that there's more than one way to deal with this, because then this turns into this x minus 2 squared, and then again minus 30, so it's the same thing. So it's good to have just a little bit of flexibility in how you think about this. So okay, let's take a look at one more. So I strongly recommend at this point that you try this one totally on your own. from start to finish. Think about what makes sense. This is like kind of a classic situation you can find yourself in an integral. So try to complete the square on this and then hit play when you're ready. Okay, so you'll remember that I said that I think it's better to have a 1 for the coefficient here. So what I'm going to do is I'm going to factor out the negative from just the x's. And I'm going to leave this plus 6 over here. And so now I can go through my happy little completing the square. And so I can now add that 1 here. But remember, I need to now back this out. I need to have the reverse operation of what I've done here. And this is where this kind of can mess with you a little bit. Because what is this 1 being bounced off of? It's ultimately being bounced off of a negative. So really what's happening here is that I have a negative 1, right? 1 times this negative. So I've really brought in a negative 1. So to offset this negative 1, I need to put a positive 1 out here. And okay, so then I can finish completing the square. So I have this x plus 1 squared plus 7. And very often what we do when we're integrating is we like reverse the order like this, and then we kind of go about our business. Okay, so that is just a quick reminder of how completing the square works. I have other videos where I will talk about using it in integration, but I figured it might be helpful just to zero in on this skill for a minute. So if this is helpful, consider hitting that like button or that subscribe button. And I'll catch you guys in another video, hopefully. Bye.